Hello, everybody. I'm really excited to be here in Tel Aviv today and talk to you about Prisma and specifically how to make your databases type-safe using tools that we're building. So my name is Nikolas Burk. I lead the developer advocacy team at Prisma. We're a startup based in Berlin, and we're really focused on improving the developer experience for everybody who works with databases. We don't build our own database, but we're building a lot of tools that are supposed to make your life easier when you're working with a database. And apologies up front, because I'm going to be that guy today. Who of you is using TypeScript in their production applications, actually? All right, I would say that's maybe half of the people. If you're using TypeScript in your production application that you're working on day to day. Yes, about 50%, I would say. All right, so the agenda that I have for today is that I want to start with the what and why of type safety. What is it and why is it important to us as developers? Then I want to talk about some technologies that help us to make our stack type safe. And then I want to show you how you can make your database type safe, specifically with Prisma. I'm also going to give a little bit of a demo so that you actually see how Prisma works live. And then I'll draw a conclusion with a couple of takeaways. So let's jump in with the questions about type safety. What is it and why? And for this, I kind of came up with my own definition of type safety, and that goes as follows. Type safety is a property of a programming language that determines to what extent a program can encounter type errors. So what's a type error? A type error is an error that occurs when the program is instructed to perform an operation on a value or object on which that operation is not actually defined. So if we're thinking in programming terms, then you could think of a string, for example, that is a data type, and you can perform an operation like add on this data type because that's an operation that you would perform with an integer. If we think about a real-world analogy for this, and we think about what would types actually be in the real world, types are really just categories of things, right? They are structures. So in the real world, a type could be a cat, for example. And a type error could be if I tell my cat to bark, because it's not a dog, it can't bark, so that's a type error in the real world. Or if I use a hammer to drill a hole in the wall, that's also type error. I'm using something for a thing that it's not intended to be used for. So common type errors in JavaScript that probably a lot of you have seen actually is something like this. Type error, cannot read properties of null. Type error, hello world is not a function. Type error, cannot set properties of undefined, and type error, string.add is not a function. So these are all exceptions that can be thrown in your JavaScript application, and they will make your program crash. To illustrate the benefits of type safety and what it actually is, what it looks like, I want to switch to a little demo that's just based on this one little function, get full name, we're passing in a user object, and then we are just concatenating the first name and the last name of this user object to return some value. And for that, I have prepared this very plain Node.js project here. So we can see that we have literally no dependencies here at the moment. And inside index.js, we also just have the full name function that I have presented before, and then 4 different ways of potentially calling this function. And I want to just go through all of these ways to examine the results of the different function calls. So the first one here is actually going to produce an actual exception. And it has exactly one of the type errors that you saw on the screen before. Cannot read properties of undefined reading first name. But not all of the type errors that can occur actually happen or lead to an exception and lead to a crash of your application. It can also just be that the type errors lead to unexpected behavior. So if we're calling the function with the wrong structure of our arguments, it just happens that the result is just going to be undefined, as it's printed right here. Similar things are happening when we're introducing typos in the function call, and we are not properly casing the first name and last name properties here. So when I call node index.js again, we just read undefined. So finally, the right way of how the author of this function probably intended this function to be called was like this. Get full name and then first name and last name in an object that we're passing in there. And if I do this, then I have to save my file, but then we actually see the desired result. So That's how the type safety or the lack of type safety can trip you up in your application, because as a consumer of this function, you're not really sure what this argument is supposed to be, and you can pass into the function whatever you want. There is no help from the editor. So now I want to show you how you can very quickly migrate this plain JavaScript app into TypeScript, and then with that, actually go ahead and use the help of the TypeScript compiler to fix all of these issues. So for that, I'm going to install 3 dependencies here. The first one is the TypeScript dependency that gives me the TSC language compiler. The second one is tsnode. That's basically just the equivalent of the node command that you just see that I use to run the index.js file, and then the types for node as well. And I install all of these as development dependencies, and they are now in my package.json file. So now we can already see, or actually not yet, I still have to initialize TypeScript here. And the way how I'm going to do this is with the npx tsc init command. That's going to create a default tsconfig JSON that I need in every TypeScript project. And finally, I'm going to rename my index.js file to index.ts. And this is it. We already have a working TypeScript project now, and we can already see the benefits of TypeScript and the TypeScript compiler right here, because it yells at me and tells me that parameter user at the moment has an implicit type. In fact, if we uncomment the rest here, we will see that we will get more errors that are already thrown by the TypeScript compiler. This one isn't picked up yet. So let's actually go ahead and fix everything by defining a proper type here with a user that now has a first name and a last name, and make sure that this is now of type user. So get full name, it tells me that the user argument was not provided. This one tells me that I passed 2 arguments where 1 was expected. This one catches the typo. It only catches the first one. So if I comment this out, then the same error will occur here. And literally, this is the only one that is going through. So this is the benefits that we are getting with TypeScript. We're catching all of these very simple, stupid errors that nobody of us wants to really think about when we're writing code, using the TypeScript compiler ahead of time before we are deploying our app to our users. And with that, let's get back to the slides and review some of the big benefits that you get when you are using TypeScript in your application. And the first one that I want to point out here is that you catch the errors at compile time. When we think about building applications, we can typically think about at least 3 stages of development, right? The first one is we're at development time, we're sitting in front of our editor, we're writing code. The second one is the compile time. That's when we're using TypeScript, the TypeScript compiler, to compile the TypeScript code to plain JavaScript. And finally, we have the runtime. And we don't want to catch errors at runtime. That's when the app is actually in the hands of our users, and a crash is virtually the worst thing that could happen to our users at runtime. So we really want to catch errors at compile time, and that's one of the big benefits that you're getting with TypeScript. The second big benefit that you're getting with TypeScript is that you can refactor with confidence. So here I have a little GIF that shows you what happens when you rename a variable in a file that uses TypeScript and inside of VS Code. And you can see how immediately after I renamed the file, the variable name, the TypeScript compiler is putting red squiggly lines on each occurrence of that variable. The next one is the autocompletion and the Intellisense. And that's also a really, really nice feature that helps you with your productivity, because you can just hit Control Space in your editor, and you see all of the options that you can use at this point for an object or for a function where you have to pass arguments in. So this Control Space has really become a default part of my workflow when I'm writing applications. The next one is that types also serve as documentation, especially when we're in a team setting. I think it's really, really valuable that we actually need to define types and others can understand what we wanted to do with that particular piece of code. So it helps us to understand what the author of a certain piece of code actually intended to do. And that brings me to my last point, and that's that they really help to show the intent of what you're writing, and it helps to enforce this think before you code approach, where you really want to think about what kind of problem you actually want to solve in your code beforehand, rather than just starting to write something and figuring it out. And I think that's actually a somewhat similar benefit that you get from test-driven development. With test-driven development, you also really have to think before, okay, what problem do I want to solve? What is the outcome that I want to achieve? And I think defining types has kind of a similar side benefit here. So, to sum up all of these benefits into one simple single statement, I think type safety really increases the productivity and the confidence when building applications. And yes, sorry, I sound like this guy again. So, what are the drawbacks? What's the catch with TypeScript? From the conversations I've had with TypeScript developers, and especially TypeScript newcomers that haven't worked with a statically typed language before, and maybe for whom this concept of a type also seems a little bit foreign in and by itself, the first thing that they name is that there is a learning overhead. You have to understand what types actually are, how to define them, what the syntax is, and as a beginner, I think fighting against the TypeScript compiler can be really, really frustrating at times. So you have to bring some motivation, you have to bear with the TypeScript compiler and just keep going until you understand these concepts. The second one is the actual overhead of defining types. You can't just go as you do in JavaScript and just write your application, but you actually have to think about, okay, what kind of types are you going to use? What are they going to look like in your application? So this overhead of defining types can also be substantial and can be really annoying for TypeScript developers. And finally, there's going to be a compilation time. So if you're using TypeScript, then you actually have this extra step before you can execute your code. And that's the compilation time, where you're calling the TypeScript, or you're invoking the TypeScript compiler to compile from TypeScript to JavaScript. All right, let's move on to the next section of my talk, and that's how you can make your stack type safe. And in this section, I particularly want to talk about some technologies that help you to get end-to-end type safety across your entire application stack. And we've already seen the benefits of TypeScript, but by default, they apply only to a single piece of software that's deployed somewhere. And if we think about how we're building applications, then we typically build applications in this model where we have different kinds of applications, a client application, a server application that we deploy separately. Maybe we have microservices. So how do we maintain the type safety across network boundaries in our application? If we think about this kind of very typical three-tier architecture that I think a lot of us are familiar with when we're thinking about how we're building applications. We have a client, we have an API server, and we have a database. And if you want to achieve type safety between your front end and your API server, I think three really great ways of achieving these are Swagger, that's now also called OpenAPI. We have GraphQL, and we have a fairly new technology that's called TRPC that you can use when you're only using TypeScript on the front end and on the back end, but that wouldn't support, for example, a mobile client. So if you're also building an Android app or another kind of mobile app, then you wouldn't be able to use TRPC. Then maybe a tool like GraphQL would be a little bit more appropriate. On the database side, you can use tools like TypeORM, for example, or Prisma, and these also help you to make the application boundary from your API server to your database type safe. And the fundamental idea of type safety across network boundaries really is based on this idea of a contract. And a contract, in development terms, you can also think of as a schema. And here is a very brief and simple example what such a contract looks like and what it looks like when the API server and the front end both have to adhere to that contract as well. So for those of you who have worked with GraphQL, this is going to look familiar. This is probably the simplest GraphQL schema that you can design ever, but I think it helps to illustrate my point. So this would be the contract that we're defining, and that defines how the GraphQL API actually works, what kind of operations I can send against this API. Now, here, as a backend developer, we need to implement this contract. And the way how we implement this is using a resolver object There are multiple ways how you can implement these resolvers. This is the so-called schema or SDL first approach to do so. And what's important here is that actually the spelling of query and hello inside the resolvers object matches one-to-one the spelling that we have in the contract in the schema. If it didn't match it, if we had used different casing here, then the contract would be broken and the application wouldn't work anymore. And on the front-end side, this is how we would call it. We would send a GraphQL query, and again, the casing is important of this hello here, and this is how we maintain the contract on the front-end and on the back-end. But it's great that we have this intermediate schema that gives both front-end and back-end developers the security and the certainty about what kind of operations can be performed against the API. All right, let's move on to the part where we talk about databases with Prisma. So first of all, I already briefly mentioned this in the beginning, but Prisma really is supposed to make working with databases easy. It should increase the developer experience. It should make you more productive, more confident with your database workflows. And when we think about what kind of workflows we typically have with databases, I think we can think about three broad categories. The first one is data modeling. So the first step really is we have to figure out what's the shape and the structure of our data that we need to put into our database. The second one is then migration. So after we've decided on the data model, we still have to actually map this data model to the database and make sure that the tables correspond to that data model that we've thought about. And finally, we need to query the database in our application to actually implement the API or whatever application that we want to build. So these are the three main workflows that Prisma supports. And why is it that we call it zero-cost type safety with Prisma? Well, if you're thinking back to the drawbacks that I named initially for working with TypeScript, I think one of the main drawbacks really that I hear over and over when talking to TypeScript engineers is that they need to define the types for everything, especially when you're working with a database and you now have to define all of your types for the database. That can be really, really cumbersome. Maybe you have to define DTOs in your API layer, in your service layer. So there is a lot of overhead that can come just from defining your types. And Prisma solves this using code generation. And the way how it does this is that everything with Prisma always starts with this Prisma schema. The Prisma schema is a way to define your data model that will, on the one hand, be mapped to your database, and on the other hand, will also lead to TypeScript types in your application layer. And here is specifically what it looks like. So I give a very brief and simple example of a post and a model type inside of a Prisma schema. And then on the one hand, we use migrations. So we can run a Prisma CLI command to generate this SQL code that can be executed against the database. And then on the other hand, we also use code generation to also generate the corresponding TypeScript types. And we see that we have a user type and a post type, and they have the same fields that we define in the Prisma schema. And the Prisma schema here, it's the contract. It's the single source of truth for what your data looks like in the database and on your application layer. So I prepared a short demo for you where I want to highlight two features of Prisma that we're really proud of and that people repeatedly tell us that they really enjoy when they're working with Prisma. They both have to do with type safety. So here is what I've prepared for you. In fact, I'm going back to the same project that I have been using before. And here, it's already a plain TypeScript project. To remind you, we just have these three dependencies at the moment. And next, I want to install the Prisma dependency, the Prisma CLI as a dependency as well, so that I can run the Prisma commands. The next step is that I want to initialize Prisma, and I do that with the npx prisma init command. And that command is going to create a new folder called Prisma right here. It also created this .env file because we recommend that you work with your database connection strings inside of environment variables. For this demo, however, I'm going to delete it because I'm just going to use SQLite so that I don't have to bother with setting up an actual database server here. So I'm using SQLite, and as my connection, I'm going to specify a file path to a file called dev.db. And what you're looking at here is already this Prisma schema that I've talked about. It not only contains the Prisma models, these are the ones that I'm going to add in a second, but also some generators that tell the Prisma CLI what to do with the models, and then also the database connection that I've hard-coded here for SQLite. So here I'll start by now defining the same models that you've seen on the slide before. And you can see here as well that in the code editor, the VS Code extension that I have installed for Prisma also helps me with autocompletion. And I'm going to define a user model that has a first name and a last name of type string. I also want this to have an email that's also a string, and that should also be unique. And then I'm using this very quickly as some boilerplate to create a second model that I call post. So we are in the domain of a very simple blogging application where a blog article, a blog post should have a title, it should have some content, and I'll make this optional here with this little question mark. I also want there to be a Boolean flag that tells me whether this is published or not. By default, I'm going to set it to false so that every post always starts as an unpublished draft. And finally, I want to define a relation between the post and the user. And the first thing that I do for that is I am defining a foreign key here. That's the author ID that's pointing to this ID of the user. And then I also can define this relation field here where I'm providing a relation attribute and point it to the ID of the user. Now, the Prisma VS Code extension gives me red squiggly lines because in Prisma, I always need to define relations on both sides of the model. And that's what the final version of this Prisma schema looks like. We have a user and a post. And now I run the Prisma migrate dev command that is going to look at this data model. It's going to generate the SQL for it. And after that, it it executes the SQL against the database. And if you put these two against each other, at least I hope that you also, like me, find the left version a little bit more readable than the plain SQL that's generated here. All right, what can I do with this now? I can now start to query my database. And I have prepared a little bit of boilerplate here that I'm going to show. So it's literally just, again, a super simple TypeScript script that has a like main function in which I can use promises with a await. And here I want to write my first query to create a new user. And you can see again that right now, to write this query, I'm simply going to follow the autocompletion here. And I'm going to create a user in the database. If you've seen Yoni's keynote right now, a few minutes ago, then you know this, and maybe someday this might happen. So if I run this query now, I can create a new user in my database with this data. But the nice thing about Prisma is that it provides a really developer-friendly API also for more complicated queries. So in this case, I can already do a nested write, as we call it, and create a post for Yoni's user in the database as well. So let me log this to the terminal and execute this with tsnode. Oh, this is outside of the main function. But the user was already created, so I'm actually not going to run this again, but instead I'm quickly going to invoke Prisma Studio, because if I run it again, or, no, was it not? Am I not calling the main function? Let's see. I'm not using await. OK. So now that I run this, I expect that the user is being printed here. And if I run Prisma Studio, which is a GUI to manage the data inside of your database, you can also see that both the user and the post have been created. All right, so that's one cool feature of Prisma, these nested writes. But I now want to show you more features that have to do with type safety specifically. So to retrieve a user, I can use the find first function. And if I run this and log the user, I expect to just see the user that I just created printed to the console. So that's great, but sometimes we only want to retrieve a subset of the fields of a user. And in this case, for Prisma, we can use the select option here. And in there, we can say that we only want the first name and the last name to be returned, for example. And if I do this, then, and run the application again, then we'll see that we actually only get the first name and the last name back. But the cool thing here is that we also get the static typings for this user object. So now if I want to access a property on the user, I only get the suggestions for first name and last name. And if I were to access a property that actually doesn't exist, that I haven't retrieved, then I get a type error as well. And that's a huge, huge protection for really stupid mistakes that you could do when you're working with a database, and that the majority of other kind of database tools don't actually provide. The same thing, the same kind of type safety you also get when you're using relation queries. So here I can specify that I want to retrieve the relation that I have defined in my Prisma schema as well. So now I want to retrieve the user, including all their posts. And we see that we now have this post property that gets returned as well. And we can even go and nest this more deeply by saying, OK, we only want the ID of the post to be returned. And this is all going to be reflected not only in the output here, but again, also in the types that we actually have on this user object. So that's the first thing that I wanted to show. And the second feature is a brand new feature that we just released for production actually last week. And that's called Prisma Client Extensions. And here what I want to show you is how you can write a function, an extension that is adding a computed field to this user object. So again, I'm going to follow the autocompletion, and there are 4 different kinds of extensions you can write. Client adds static methods to your Prisma client instance. Model adds methods to your Prisma models. And query and result extensions are to intercept the query lifecycle, and I want to modify the result. Here I specify on which model I want to add this computed field. And here I can give the name to this. And now I can specify what kind of fields I need. And to compute the full name of a user, I need the first name and the last name. And the computation for that is going to look very similar to what we've seen in my very first demo with user.firstname and user.lastname. And if I now run this code here, because Prisma Client is now extended, in fact, this user type, it already should show me it did show me the extended full name here. So if I run this, then I expect to see the full name being returned here as well. So that's how you can add type-safe computed fields to your application with Prisma as well. I'm going back to my slides that are here. All right, so in this talk, I talked about how you can actually use these really neat type-safe features that Prisma gives you. But if you're interested in how this actually works, what's happening under the hood, my former colleague Tim, who now went on to found another company called GraphCDN, now called Stellate, he gave a really, really deep TypeScript talk, very technical, about how we're achieving the type safety in relation queries through a combination of generics, conditional types, and map types. And that's a really interesting talk if you're a TypeScript aficionado and you want to learn about how this actually works under the hood. So let's draw some conclusions from this talk. The first one is that type safety really, really increases the confidence and the productivity when you're building applications. But type safety also comes with the overhead of defining the types in your application, which is solved by Prisma through code generation. And that's all I have for you today. Thank you so much.